All right, so for today, we are talking about sketching angles, finding reference angles, arc length, and sector area. We are going to review just a little bit with coterminal angles and converting from degrees to radians. So if you have an angle such as 8 pi over 3, and you're trying to find a coterminal angle that lies in between 0 and 2 pi, first off, 2 pi is what as a degree? 360. So essentially you're looking basically amongst from 0 to 360 within that one circle. Right now, 8 pi over 3 is actually bigger than 2 pi, okay? Because if you think about it, 2 pi with a denominator of 3 would actually be what? 6 pi. So 8 pi is bigger than 2 pi. To get a coterminal angle that's in between 0 and 2 pi, I'm going to need to do what to 8 pi? Subtract what? 6 pi over 3 or 2 pi. So then that's how you get your answer of 2 pi over 3, which does lie in between 0 and 2 pi. Let's practice sketching some angles, okay? You guys can do this on your desk, be in the classroom. You can do it on a sheet of paper at home. But let's get this whole idea of making sure you guys are able to sketch angles. First off, when you sketch an angle, it needs to be in standard position. We talked about what standard position was last class. The initial side of the angle is where? On the positive x-axis. So it's always fixed to the positive x-axis. The initial side always is. Then the terminal side is the side that lies within one of the quadrants or maybe on another one of the axes to represent this angle. Now, radians usually is harder for students, okay, for whatever reason. 0 is always here. We know that this one at the top is 90 degrees, but we're in radian. So what is 90 degrees as a radian? Then this side over here, this is 180 degrees, but in radians is what? This one down here at the bottom is 270 degrees. If you think about it, all I'm doing is going 90 degrees, 90 degrees, 90 degrees. But I need to convert this into radians. So what is 270 as a radian? 3 pi over 2. Very good. And then when you go a full 360 degrees, yes, you're back at 0, but you've already gone a full turnaround. So what is that? 2 pi, okay? So if you're trying to figure out, okay, exactly where does 3 pi over 4 lie, kind of look at it like this. Take the pi's out of the equation and just look at the number, right? You have 0, 1/2, 1, 3/2, 2. If I take out the pi here, I'm looking at 3/4. Is 3/4 in between 0 and 1/2? Is it in between 1/2 and 1? Yes. So your terminal side lies in the second quadrant. Where specifically in the second quadrant? To be honest, I'm not concerned as long as it's in the correct quadrant. Okay? But use that. Take out the pi's and just look at the number. Okay? Where does 3/4 lie? It's in the second quadrant. How is Ms. Anderson going to know that you're talking about a positive angle, a positive 3 pi over 4? I need to start at my initial side and go counterclockwise. Remember, counterclockwise represents a positive angle, clockwise represents a negative angle, and then of course, this couldn't hurt either, okay? But make sure you always start on your initial side for positive angles going counterclockwise, and you also have the arrow that's pointing there, okay? Can someone give me an angle that's coterminal to 3 pi over 4? Can someone give me an angle that's coterminal to 3 pi over 4? Go ahead.
I said negative 5 pi over 4.
Very good, negative 5 pi over 4. That is a coterminal angle to 3 pi over 4. Coterminal angles have the same initial side and the same terminal side. It's just it's a matter of revolutions that you have, okay? Since this is a negative angle, I'm going clockwise. And if I'm going clockwise, let's use this color. The radians, all they do, they reverse. This is still 0. This one, if I'm going clockwise, is a negative pi over 2. This one here is a negative pi. This one here is a,
Negative 3 pi.
and the last one is,
Negative.
okay? So negative 5 pi over 4, it's not like I'm going around multiple times with my little curve, my little arc, okay? I'm literally, again, still starting my initial side, going clockwise and ending exactly where that terminal side is. And this is how we sketch angles, not just normal angles, but coterminal angles as well. We'll do one more before we try the next one. Can someone give me another coterminal angle for 3 pi over 4?
7 pi over 4.
No, not 7 pi over 4.
11 pi. 11.
11 pi over 4. Very good. We get 11 pi over 4 by adding 8 pi over 4 to the original. Now 11 pi over 4. Using your knowledge, a little bit of being a little inquisitive here. 11 pi over 4. That's bigger than 2 pi, is it not? 11 divided by 4 is like 2 3/4. So that means I've gone around completely one full time, and then I've gone another 3/4 of the way. So I still have the same initial side, the same terminal side. I've just gone around one full revolution, and I've ended back at my terminal side. Did everybody catch that?
Yeah.
To make this consistent with video's sake. Those are my different angles. Is everyone good? Let's try one that's degrees. Like I said, sometimes degrees are a little bit easier.
How did you get 8 pi over 4? I'm sorry.
8 pi over 4? Remember, that's nothing but 2 pi.
2 pi. Oh, yeah.
So then that way I can add it easily. All right, let's label my axes here. This is 0. Since it's a positive angle, I'm going clockwise or counter. So this is, keep going,
180,
keep going,
270,
and then
360.
if I wanted to keep going clearly, because 500 is bigger than 360, all I do is add 90 degrees on to 360. What's 90 plus 360?
450.
What is it?
Oh,
450.
450. Okay. 500 is a little bit bigger than 450, correct?
It is.
So that means I'm in the second quadrant again. So my initial side is here on the positive x-axis. My terminal side is in the second quadrant. Again, I don't care how far in the second quadrant it is, as long as it's in the second quadrant. And since we went around one full revolution, one full 360, I have to draw my curve to represent 360 degrees. And then the remaining 140. So then this would represent 500 degrees. So might give me a coterminal angle to 500 degrees.
860.
So, what's 360 plus 360?
720.
720. 720 would be me going around 2 times, which is what I'm gonna have to do here. So that's once, 360 degrees, twice, 720. 860 is gonna put me back at the same terminal side just after going around 2 full times. Questions on sketching angles. All right, so here's an example of an angle sketched negative 300 degrees, okay? This is a really great drawing because not only is it in the correct quadrant, which is quadrant 1, it's heading in the clockwise direction with the arrow, and the labeling couldn't hurt either. Now, there was a question that was brought up about what if the angle actually lies on the terminal side or on the initial side. That can very well happen. When that happens, it's super important that change the color too. That if your initial side and your terminal side are on the exact same place, that you include the arrow along with the direction, okay? Because then it'll indicate that, yes, this represents a 360-degree angle versus a negative 360-degree angle. I'm not gonna know, especially if they lie one on top of the other. So for this particular example, I asked you to find one coterminal angle to 11 pi over 3 and then sketch both 11 pi over 3 and your coterminal angle. So this one, done beautifully, okay? For those who may be struggling with the actual, like the radian ones, okay, remember this one is 0, this one's pi over 2, this one's pi, this one's 3 pi over 2, and this one is 2 pi once we go all the way around one time. Now, I said take away the pi's and just look at the numbers, right? 11 over 3 is what? Like, if you divide them. 11 over 3 is what? 3 2/3, right? So I have 0, 1/2, 1, 3/2, 2. If I need 3 2/3, well, I need to go to 3 pi, which would be over here, which will make this 4 pi. So I need 3 2/3. 2/3 is bigger than an extra half, so that's why it's in the 4th quadrant. And I've gone around one time for the 2 pi. Here's 3 pi, and then there's that remaining 2/3. So that was perfect. Coterminal, this particular student decided to go down instead of up. And so they subtracted 6 pi over 3, and that's how they got 5 pi over 3 for their coterminal angle. So then they only had to go around not even one full time just to meet it back up there. This is how you sketch angles and also with their coterminal angles. So going into our notes to get our sheet on reference angles. Reference angles is denoted with the theta symbol and an apostrophe. That is the symbol for reference angle. It is an angle that's formed by the terminal side of your angle in standard position, of course. We only work with standard position, so that means the initial side is on the positive x-axis and the x-axis, whether it's the positive x-axis or the negative x-axis. But reference angles are formed between the terminal side and the x-axis. The main thing is that you want to make sure, and I know this is blurry to see, but it should be clear on your notes, is that theta, whatever the angle is, should be in between 0 and 360 if we're dealing with degrees, or between 0 and 2 pi if you're dealing with radians. Otherwise, these formulas that you see on your paper are not going to work. So let's say that I give you an angle that's 420 degrees and I want you to find its reference angle. Well, 420 degrees is not in between 0 and 360. So what does that mean? Don't overthink it. I need to find the coterminal angle to it that is in between 0 and 360. So what do? Subtract 360. So 60 is the coterminal angle to 420. I can work with 60 to find my reference angle, and it's going to be the same reference angle for 420. and whatever other coterminal angles go with 420. So once your angle is in between 0 and 360 or 0 and 2 pi, you see, is it in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Well, 60 degrees is in quadrant what? 1. So your reference angle is that angle because it's the distance between the terminal side and the x-axis. Okay? Let's say your angle was 135 degrees. Well, theta is originally in between 0 and 360. I don't have to do any coterminal angles or anything. 135 degrees, is that in quadrant 1, 2, 3, or 4? It would be 2, because if you think about it, this is 90, this is 180, so 135 falls in between. So then the reference angle is going to be 180 minus that angle, or pi minus that angle if I'm in radians. Okay, so I would do 180 minus 135, and I get what? 45. So 45 degrees would be my reference angle for 135 degrees. Is everybody following me? Let's look at a radian. 5 pi over 4. Use your knowledge. This is 0. This is pi over 2. This is pi, 3 pi over 2, and 2 pi. What quadrant does 5 pi over 4 lie in? The third quadrant, because it's bigger than 1, but less than 1.5. 1 and 1/2. So the reference angle is going to be theta minus pi. Well, here's theta. I need to subtract it from pi. How do I subtract 5 pi over 4 from a pi?
You have to make sure the denominators are the same.
So what do I do there? Very good. And what's 5 pi over 4 minus 4 pi over 4? So my reference angle for 5 pi over 4 is pi over 4. And I can do the exact same thing with the angle that's in quadrant 4. But what do you notice between every single one of these reference angles? 60, 45 degrees, pi over 4. Every single one of these reference angles are what? Huh? Yes, they're positive. So they're always positive,
They're all less than 90.
which means they are, what word means less than 90?
They're
Acute.
cute.
Very good. Reference angles are always acute because they're so cute, okay? Reference angles are always acute. So let's look at this here. Let's look at this one here. We're going to sketch 3 pi over 4, then find its reference angle. Again, another radian. I'm going to go ahead and label my axes so you guys can have a better idea of where 3 pi over 4, what quadrant it lies in. What quadrant does it lie in? The second. So my angle, initial side, terminal side, there's my angle, 3 pi over 4. So since it lies in quadrant 2, to find my reference angle, I have to do pi minus theta. So that's going to be pi minus 3/4. How should I rewrite pi so that way I can subtract them? So what's that answer? So my reference angle for 3 pi over 4 is pi over 4. Let's look at this one. This one's negative, so I'm going what direction? Clockwise.
Clockwise.
Good job. Negative 150 degrees lies in what quadrant? Lies in quadrant 3. Very good. Going clockwise. That's theta. It's only got one issue though. In order for me to use those formulas, that angle has to be in between 0 and 360. So what should I do? A positive coterminal angle, so that means I need to, what 360? So what's negative 150 plus 360? 210. So now I can use that formula for the third quadrant to say that the reference angle is theta minus 180. So what's 210 minus 180?
30.
30. Now, some of you guys may be able to recognize that like, oh, well, the distance between here is nothing but 30 degrees. And since my reference angle always has to be positive, it's got to be a positive 30. You can do that too. But you got a formula there to help you if you need it. You can't visualize it. One more, and then I'm gonna have you guys try probably one on your own. Because I think this is an easy concept, but I don't know. 520, it's really large. Is that in between 0 and 360?
No.
So I need to find the coterminal angle, so I'm gonna need to what, 360? What's 520 minus 360? Very good. 160, that's the coterminal angle to 520. Is 160 in the first, second, third, or fourth quadrant? Second.
Second.
Very good. So to find my reference angle, I need to do 180 minus theta, my coterminal angle theta. So then what's my reference angle? And every single time reference angles are positive and they're acute. Isn't that right, Luke?
All week.
All right. Finding the reference angle for negative 19 pi over 18. I'm gonna work this one out because I didn't really get much work from you guys online or in your responses. First off, this is a negative angle, which I can't have, so I need to find a coterminal angle here, okay? So that means I'm gonna add 2 pi or 36 pi over 18. That is 2 pi. So when I add that, that's going to give me a 17 pi over 18 as the angle I'm going to use to know that it does lie in the second quadrant. Actually, in the negative direction for negative 19 pi over 18. But since I am in the second quadrant, that means I need to use the formula of pi minus theta to get my reference angle. Now, like I said, a lot of you guys did get the correct angle. I just don't know how you got it. Maybe I shouldn't ask any questions, right? Just trust that you didn't Google it. Big trust, yes. All right. There are no questions, then we're gonna wrap it up then with applications. Inside of your packet is the paper that says applications on the side. Finishing it up with arc length and sector area. If theta is a central angle in a circle of radius r, then the length of the intercepted arc is given by the formula S equals r theta. S equals r theta is your formula for arc length. So where it says arc length and there's this picture of this circle, you should write down that formula, S equals r theta, where S is equal to arc length, R is equal to radius, and theta, of course, is your angle, where theta is measured in radians. That is so important. Please make sure you make a note that theta has got to be in radians. Otherwise, you are not going to get the correct arc length. Arc length is essentially part of your circumference. that is arc length, okay? So this right here represents the length of your arc. It is part of your circumference. Theta is the angle that is the same distance as, that essentially creates that arc. And more specifically, is called your central angle. The reason why it's called your central angle is because its vertex is at the center. It's central angle, okay?
We're not supposed to have this on our paper, right? We're supposed to write it down.
I mean, I'm just giving you bits of extra information. Yep. So to find the length of your arc, you need to take your central angle value and you multiply by your radius as long as your angle is in radian. So if we look at this very first example, which is on your actual foldable, it says the length of the intercepted arc in a circle with central angle measured pi/3 and a radius of 4 inches. Rounded to the nearest tenth. That means you have a circle that has a radius of 4 and a central angle. Again, this is where the angle, the vertex of the angles in the center is pi/3. To find the length of your arc, you need to use the formula S is equal to R theta. And theta has got to be a what? Is it a radian right now?
Yes.
Yes. If it wasn't a radian, what would I have to do? Convert it.
Convert.
Very good. So then all I do is I just take the radius and I multiply it by the angle. This is going to be 4 pi/3 inches. But since it asks us to round to the nearest tenth, can someone do 4 times pi divided by 3 in their calculator to get it and round it to the nearest tenth, since that's how the question told me to round? 4 pi divided by 3?
4.2.
4.2. So it'll be 4.2 inches. 4 pi/3 would be the exact length of the arc, but it did ask us to round it. Okay? That's how you find arc length. You take your central angle, that's a radian, and you multiply it by your radius. Now let's say they gave you a problem, or I gave you a problem, it's not they, it's me. Sorry, I'm used to speaking in the different notation. Let's say that instead you were given that this, the radius was 5, and then they told you that this was 80 degrees. 80 degrees does not represent the length of the arc. It represents the fraction of the circle that arc is comprised of, okay? So if 80 degrees represents the fraction of that 360-degree circle, then that means the angle is 80 degrees, okay? You would have learned this back in geometry. Central angles are the measure of its arc. But in order for me to find the length of that arc, what am I going to need to do to 80? I need to convert it to a radian. How do I convert 80 degrees into a radian? So that's going to turn into, divide by 2, that's going to be 4 pi/9. That's my angle. And then I just have to multiply by my radius to get my arc length, and so on and so forth. Area of a sector, the one at the very bottom, the one at the very bottom. To find the area of a sector with a radius of r and a central angle of theta, it is A equals 1/2 r squared theta, where theta is measured in radians. Where theta is measured in radians still. Sector area is like that piece of pizza that you take out of the pie. It is that entire section. So you're finding essentially a part of the area of the entire circle. You just take the radius, square it, multiply by the angle, the central angle, which is measured in radians, and then divide by 2. Simple enough, yeah? Let's look at this one. I'm finding the area of the sector. That's the formula, 1/2 r squared theta. What's my radius? What's my angle? My angle has to be what? It will be pi over 3. It has got to be a radian. So you need to convert 60 degrees to a radian. Then you'll be able to actually find the area. So this becomes 64 over 2, which is 32, pi over 3. This will be known as your exact area, because I don't actually multiply out the pi and round. But can someone do 32 pi divided by 3 and give me that number in 3 significant figures? Because that's how I want you to round 3 significant figures unless the problem tells you otherwise.
It's 33.5.
Very good. And of course, we can't forget our units because we are talking about area, that's feet squared. Length is just the unit. And so we kind of did a little hodgepodge of a lot of things. We did area of a sector. Remember, a sector is essentially that piece that you take from the pie, okay? You take half of your radius squared times your angle, which got to be in radians. The angle is called your central angle. And again, it has got to be in radians. Arc length is a part of the circumference, all right? It's that pink part, that outside part of your circle. And that is found by taking your radius and multiplying it by theta. We also talked about how to find reference angles. Reference angles are always acute, and we want to make sure that the reference angle always lies in between the terminal side and the x-axis. And then, of course, we cannot forget coterminal angles, how to sketch them, converting between radians and degrees.